For 40 years, a central belief about hiring tests has shaped millions of careers and even court cases. But what if I told you that belief was all based on a statistical illusion? What if the very tools we use to measure fairness have been, well, fundamentally broken all along?
It's a huge question, right? When you take a pre-employment test, you hope it's a fair shot. And for decades, the experts gave us a surprisingly consistent and maybe even reassuring answer.
Now this quote here, it pretty much sums up 40 years of research. The consensus was clear. Most hiring tests are not biased against minority groups. In fact, when any bias was found, it seemed to favor them by overpredicting how well they do on the job. This wasn't just a hunch. This was treated as established fact.
But one groundbreaking study came along and challenged that entire consensus. So here's our roadmap for unpacking it. First, we'll look at that 40-year consensus. Then, we'll investigate the strange case of the missing bias and how that created an illusion of fairness. We'll look at the incredible simulation that blew the lid off the whole thing. And finally, ask what this all means for rethinking fairness in hiring.
Okay, so to really get our heads around this 40-year consensus, we first need to understand what test bias actually means from a statistical point of view.
So a hiring test is basically a tool to predict your future job performance. It's considered biased if that prediction works differently for different groups of people. And statistically, this shows up in two main flavors: intercept bias and slope bias.
Intercept bias is when a test consistently over or under predicts performance for a whole group. But slope bias, that's much more serious. That means the test's ability to predict success is fundamentally different for each group. A high score for someone in one group might be a great predictor of success, but for someone in another group, that same high score might not mean much at all.
So for decades, researchers kept finding that intercept bias, the kind that seemed to overpredict minority performance, but they almost never found the really serious slope bias. And this created a huge puzzle. Why was the more dangerous form of bias completely missing, and why did the bias we did find seem so counterintuitive?
And that leads us right into the mystery of the missing bias. If our theories suggest that slope bias should exist, then where on earth has it been hiding for 40 years?
The answer is almost shockingly simple. Our tools were never powerful enough to find it in the first place. Imagine trying to find a lost key in a massive field at night, but all you have is a single candle. The odds of you actually finding that key, well, they're pretty much zero.
Just how low were the odds? Well, a major influential study from 1999 that proudly concluded there was no slope bias actually only had a 5.1% chance of detecting it if it was there. That means there was a 95% chance of failure. You have better odds of rolling a specific number on a 20-sided die.
And this wasn't just a one-off problem. It was systemic. A lot of the common research practices had these built-in power killers, things like tiny sample sizes, unequal groups, and unreliable data. Each one of those flaws was like another gust of wind blowing out our candle, making it basically impossible to find the truth.
So if our tools were too weak to find the real serious bias, that raises a brand new question. Why were they so consistently finding that other kind of bias, the intercept bias? And here's where the story takes a fascinating turn. The answer is, it wasn't real. It was a statistical illusion, like looking into a funhouse mirror that you know is going to distort your reflection in a predictable way. Our own methods were creating a false signal of bias that didn't actually exist in the real world.
So how do you create this illusion? It's scarily simple. You start with a test that is perfectly fair, zero bias. Then you just add two very common real-world factors, a test that isn't perfectly reliable and a pre-existing score gap between the groups. That's it. You run the standard statistical analysis, and voila, the math itself creates the illusion of bias. It's a ghost in the machine.
Now, this was a powerful theory. But to overturn a 40-year-old scientific consensus, you need more than just a theory. You need overwhelming proof. So, the researchers ran one of the most exhaustive computer simulations ever conducted on this topic.
They started by designing over 3.1 million unique scenarios. Each one was built to mimic different real-world hiring conditions you might find.
Then, from those millions of scenarios, they generated a mind-boggling 15.9 billion virtual samples of test takers.
And in total, they analyzed over 8.6 trillion individual data points. I mean, the sheer scale of this allowed them to see what had been invisible for decades. It was like they finally flipped a switch and turned on a massive floodlight in that dark field.
And the findings were an absolute bombshell. The simulation proved their theory, dead to rights. Our ability to detect real slope bias was incredibly low. Meanwhile, our chances of falsely detecting the imaginary intercept bias were incredibly high. For 40 years, our tools were completely broken. We were basically set up to miss the real problem and find an imaginary one instead.
So what on earth does this all mean? If 40 years of research, of court decisions, of hiring practices are based on a flawed premise, the implications are enormous. And that brings us to our final section, rethinking fairness in hiring.
For 4 decades, the very procedure we trusted to make sure tests were fair was itself biased. It was steering us away from a real potential problem while creating the illusion of a different one. The watchdog wasn't just asleep on the job. It was barking at shadows.
Now, this is the crucial takeaway. This research doesn't prove that all tests are biased. What it proves is that our method for checking them is broken. We thought we had a clean bill of health for our tests, but it turns out the doctor was using a broken thermometer the whole time. We actually have no idea if widespread slope bias exists because we've never had the right tools to look for it. We have to reevaluate everything.
The old consensus is shattered. The bedrock assumptions that guided hiring practices for generations are now in serious question. So the work now begins. If the tools we've been using to measure fairness are broken, how do we start building better ones? And more importantly, what will we find when we finally start looking with clear eyes?